Hi friends, in this video let us revise signals and system which is helpful for TRB exam, right? So in signals and system we are having two subjects, one is SS and another one is DSP, right? So the maximum mark is given for SS. We can expect around 70% of marks from signals and system. In DSP we can expect 30% mark, right? So SS is very important. Let us revise, right? So we will start with signal definition. What is signal? Signal is a physical quantity, right? So it is a physical quantity which is a function of independent variable, which is a function of independent variable. What about system? The definition for system is it is a device which operates on basic signal, which operates on a signal, and produces another signal. This is the definition of system, right? So whenever we study signal system, we must know about some standard signals. That is the first thing we should learn. The main signal is step signal. Next, ramp. Third one, parabolic. Last but not least is impulse. Right? So these are all the four fundamental basic standard signals we must know. Right? Okay. So next thing we have to know is we broadly classify signals as two types. One is continuous time signal. Second one is discrete time signal. Right? So as the name itself is telling, continuous time signal is having time as continuous, right? So we know for any signal x-axis is time, y-axis is amplitude, right? If it takes continuous amount of time, right? So this is called continuous time signal. You see the time is continuous. For every time we have amplitude, that is called continuous time signal. Time is continuous. There is no gap. That is called continuous. Whereas discrete time signal, it is available only at a discrete instant of time. Right? So here you see the signal is having value at only the following instant 1, 2, 3, 4, 5, right? So this is the example of discrete time signal. This is the example of continuous time signal. You see, the signal is having only value at this point, this point, this point, and this point. Only 5 points, right? So this is called the discrete time signal, right? So whenever you want to convert, this is the naturally available signal. Whatever I'm talking now is continuous time signal. Whatever you hear is continuous time signal. This is naturally available. Whatever we see, that is continuous in time. This is man-made signal. So when you want to convert a continuous time signal into discrete time signal, the thing you have to do is sampling. Sampling converts continuous time signal into discrete time signal. So if you want to convert this into this, you have to do sample. If you want to get back this continuous time signal from this discrete time signal, what you have to do? You have to sample at the rate of 2f. So f max, I can say f max is the maximum frequency of message or input signal, right? So fs is sampling frequency, right? So this is for problem solving. In reality, Fs must be greater than 2f max. This is practical one. This is for solving the problem in the exams, right? So this theorem is proposed by Nyquist. That is why it is called the Nyquist sampling theorem. So Nyquist sampling theorem in general I can write as Fs must be greater than 2f max. Right? Okay. Suppose if I have a signal like this, you see, this is 1 second t, this is amplitude. So the frequency is 2 hertz, right? So the frequency of the signal is 2 hertz. Sorry, I redraw the circuit. Right? So because what is the frequency? It is number of cycles per second. So frequency is 2 hertz. So maximum frequency of the signal is 2 hertz. So how many samples I have to take? So 2 into f max 2, that is 4 samples per second I have to take. Right? So 4 samples per second. So in 1 second I have to take 4 samples. That means what? For every second I have to take, for every 0.5 I have to take 1 sample. So this is, let us assume 0, this is 0.5, this is 1, this is 1 point. Right? So that is why we should not take in practice. These are all the 4 samples. If you take like this in practice, what we get is, it is like this. So it is very difficult to recover the signal. That's why in practice we are taking Fs is greater than 2f. But in exam we have to use this one, right? So 4 samples per second. If Fs is less than 2f, that is less than 2f max, means what will happen? It will create aliasing. Aliasing. So this is aliasing. So this will create aliasing. Aliasing means the phenomenon of high frequency signal taking form of low frequency. That is called aliasing, right? So if Nyquist sampling diagram is not satisfied, it will create aliasing. Okay, so this is the way we have to, first we have to understand this. Then we will see standard signal. Already I told some standard signal. So continuous time signal, it is represented by T, right? So T means it is continuous time signal, right? So if we are having N, means it is discrete time signal, right? So fundamental signal formula we must know. So first we will see unit impulse. Unit impulse signal del of t. The symbol for unit impulse is del of t, which is equal to 1 when t is equal to 0, which is equal to 0 when t is not equal to 0. So I can write when t is equal to 0, it is having value of 1. Right? So that's why it is having only one impulse. So it is called unit. Sorry, amplitude is 1. So it is unit impulse. If you want, this is continuous times unit impulse. If you want discrete time unit impulse, it is del n is equal to 1 when n is equal to 0. When n is not equal to 0, it is 0. So what is the thing? Then where unit impulse is having value, the unit impulse is having value only when bracket term is 0. So that is the point. Here also you see. So if I want to know how to del of t minus 2 will be there. So bracket term should be 0. When bracket term will be 0, it is at t is equal to so. So t is equal to 2, only the bracket term will be 0. At the bracket term 0 only, we will have a value of 1. So when t is equal to 2, this is having value of 1. Right? So what about del of t plus 2? So del of t plus 2, we know the bracket term should be 0. There only the impulse will be having value. So where it will be when t is equal to minus 2, this is having value 1. So this is del of t plus 2. So this is unit impulse. Next unit step. Unit step signal, the general notation is u of t. It is equal to 1 when t is greater than or equal to 0, 0 when t is less than 0. So u of t I can write as, this is when t is equal to 0 to infinity, you see when t is equal to 0 to infinity, it is having amplitude of 1. So this is u of t, right? So in discrete, I can write as u of n minus 1. Sorry, u of n, right? So u of n is equal to 1 when n is greater than or equal to 0, 0 when n is less than 0. So what will happen? So for all n is equal to 0 to infinity, you see the amplitude is 1 for n u of n. This is discrete time impulse, first step. Okay. So how u of t minus 1 will be? So what it is telling? It is telling t must be greater than 0. That means the bracket term should be greater than or equal to 0. It is 0 to infinity. So inside the bracket, it should start with 0. So when it will become 0, when t is equal to 1. So u of t minus 1 will be starting from 1. Right? So that is u of t minus 1. So similarly, how t of t plus 2, it will also start from, bracket term should start from 0. So 0 means when it will become 0, when t is equal to minus 2. When t is minus 2, it will start. So 0 to infinity. Right? So this is u of t plus 2. Then we have ramp. Right? So ramp is given by r of t. R of t is equal to t when t is greater than or equal to 0, 0 when t is less than 0. Similarly, r of n. R of n is equal to n when n is greater than or equal to 0, 0 when n is less than 0. Right? So it is unit ramp. Okay. So these are all the fundamental signal you have to know. Right? And next important thing is property of unit impulse. Some important properties they may ask from this area, questions from this area. What is this is? One is if you take x of t, any signal, and multiply with unit impulse del of t, what you get is x of 0, right? Second one is if you take x of t and convolve with del of t, what you get is x of t only, right? And summation of del of t dt is equal to 1. Then next one, if you take x of t, convolve with the del of t plus or minus t, what you get is x of t plus or minus t, right? Next, if you del of scaling property of del of t, so that is given by 1 by mod a del of t minus t by e, right? So this is another property. Sixth one, del of at can be written as 1 by a del of t. In this area, you can expect some questions. And seventh one, del of t minus a convolution with del of t minus b. That is given by del of t minus a plus b, right? So these are all the things we must remember whenever we are working with the unit impulse, right? So apart from that, we are having some many standard signals that you know. Next thing is we are having r of t, ramp signal. If you differentiate r of t, what you get is step. If you differentiate step signal, you will get impulse. Similarly, if you differentiate if you integrate impulse, you will get step. If you integrate step, you will get ramp, right? So these are all the things you must know. Next, we have even and classification of signals, right? So how we are classifying signals? Classification of signals. So first one, even and odd signals. So even and odd signal, a signal is called even when x of t is equal to x of minus t in continuous domain. In discrete domain, x of n is equal to x of minus n. Whereas signal is called odd signal if x of t is equal to minus of minus x of t, x of n is equal to minus of minus x of n. This is for continuous, this is for discrete. Okay. Then if I want to find even component of any signal, so even component of any signal xe of t is given by x of t plus x of minus t divided by 2. If you want to find odd component of any signal, o means odd, e means e, x even, x of t minus of x of minus t divided by 2, right? So in this way we can say the signal is even and odd, and we can find even component and odd component. Here you see the signal with respect to origin, the signal this is 0 1 minus 1, this is even, both the sides are mirror images, right? So I can say this is even, odd. How the signal will be odd, how can I classify? You see, this is mirror image reflected, so it is odd signal, right? So by seeing the signal itself we can find. Next, periodic signal. A signal is called periodic signal when x of t satisfies x of t plus t in continuous domain. In discrete domain, x of n is equal to n plus n, where t comma n are fundamental period. That means the signal should repeat after every particular time t. So that t is called a fundamental period. Okay. So this is the definition for periodic signal, right? So you see some. So if they ask to find fundamental period t, for t is for continuous time signal, n is for discrete time signal. For continuous time signal with the sinusoids, only these things we will deal in exam. And exponential. Exponential means complex exponential. For them, the fundamental period is 2 pi by omega, right? Simply, if your signal is x of t is equal to a sine omega t plus phi or b cos, any sine or cos. Sine or cos is called sinusoid. If it is like this, so the fundamental period is 2 pi by omega. Similarly, for a e power j omega t plus phi, right? So here also the complex exponential e power j is there, so t is equal to 2 pi by omega. So in this way we can find the fundamental period. The fundamental frequency is f is equal to 1 by t, right? So this is periodic signal. And if your signal is composite signal, x of t is equal to composite signal, that is combination of two or more signal. So how can you check whether it is periodic or not? We have to check whether t1 is periodic, first to check that. Then t2 is periodic. If both are periodic, then find t1 by t2. If both are not periodic, then it is aperiodic, right? So t1 by t2, if t1 by t2 both are periodic means, then go to next step, t1 by t2, right? If it is rational means ratio of integer. If it is rational number, then it is called x of t is periodic, else aperiodic, right? So that is the first thing you have to understand. So periodic plus aperiodic only. Okay. So if T1 is periodic, T2 is aperiodic, or T1 is aperiodic, T2 is periodic, surely it will be aperiodic only, right? So if both are periodic, still x of t may not be periodic. For that you have to go to third condition. We have to check this T1 by T2. If T1 by T2 gives rational number, then only we can say x of t is periodic. So we have to perform 3 steps whenever you want to find whether a composite signal is periodic or not. So that is very, very important point. So here we have to know some shortcut. So all continuous time sinusoids. All continuous time sinusoids are always periodic. Right? Similarly, all continuous time complex exponential are always periodic. Right? So this is the thing we have to remember. But all discrete times periodic sinusoids are not periodic. So for discrete time sinusoids, what we have to do? For discrete time sinusoids, the condition for periodicity is t is equal to n, right? N is a period of discrete time periodic signal, 2 pi by omega naught m. That must be integer value, where any is small, m is any small integer, right? So not all discrete time sinusoids are periodic. So we have to check this condition, then only we can come to the conclusion. Not all discrete time sinusoids are periodic. Sinusoids are periodic. Similarly, not all continuous time sinusoids, not all discrete time complex exponential, discrete time complex exponential are periodic. Right? So these are all the things we must remember whenever you want to work with the periodic signal. And third classification is energy and power signal. Energy and power signal, we know the signal is called energy signal. This is a very, very important point. When signal is called energy signal, when energy is finite, that is not infinite, and power is equal to 0. Only when these two conditions are satisfied, we can say the signal is energy signal, right? When a signal is called power signal, a signal is called power signal when power is finite, that is which is not infinite, and the energy is equal to infinite, right? So only when these two conditions are satisfied, then I can say the signal is power signal for both continuous time and discrete time. So the energy of the signal is given by, for continuous time signal, is minus infinity to plus infinity of t whole dt, right? And power is given by 1 by limit t tends to infinity, limit t tends to infinity 1 by t minus infinity to plus infinity mod x of t whole square dt, right? So we know energy is equal to, power is equal to, from this we understand power is equal to energy into t, right? So this may be used when you solve the problems, right? Okay, so here you must understand, whenever you want to find whether any signal is energy or power, you have to find both energy and power. When energy is finite, power is 0, then only you can say simply it is energy signal. Simply energy infinite, energy is finite, power is not equal to 0, it is not energy signal. Similarly, if you want to find power signal, you have to find both power and energy. Power should be finite, energy is infinite, then only we can say it is power signal. If one condition fails, again it is not a power signal, right? So those are the things we must be very careful. Similarly, for discrete time signal, energy is given by limit n tends to infinity, summation n goes to minus n2 plus n x of n square, right? For discrete, instead of integration, we have summation. That is the only difference. Instead of t, we have n. Similarly, for power signal, limit t tends to infinity, 1 by 2n plus 1, summation n goes to n minus n2 plus n x of n whole square, right? So wherever you find integral, replace with summation. Wherever you find t, replace with n. But here you must see why it is 2 power, instead of 2n, why I put 2 power n, that is the question. You try to answer it in the comment section, right? So why it is not simply 1 by 2 pi n, right? Okay, so this is called power signal. So here we have some shortcut point to be noted. One is periodic signals or power signal. First, so periodic signals or power signal. So whenever they give any periodic signal, blindly you can say it is power signals. Second one, right? So finite duration signals are energy signals. Finite duration signals are energy signals, right? So that is another important point. Third one is unstable signals are neither energy nor power. Are neither energy nor power signal. Nor power signals, right? So these are all the points we must know about energy and power, right? So for first one, I can give example periodic signal. We know all sinusoids are periodic, sine omega t plus phi. So it is power signal, right? Finite duration signal. What is finite duration signal? You see the signal duration t a 1, 2 to 4. So the duration is finite. So surely it must be energy signal, right? So what is unstable signal? You take ramp. Ramp is an unstable one, right? Because when t tends to infinity, it will become infinity. So this is the best example. So that is the fourth point I want to give. Del of t, right? So it is energy signal. Fine. Next, u of t, unit impulse is power signal. R of t, it is neither energy nor power, right? So these are all the things we must remember whenever we work on signals. Okay, fine. So in exam they may ask question from periodic and aperiodic, very important, and energy and power. So these are all the two areas they are concentrating mainly. So please be thorough on this, right? So more shortcuts are available in my EC8451 signals and system videos, right? So in that playlist, you will get detailed concept and the shortcuts in EC8451 signals and system playlist, right? Okay. Next we go to system, right? So in system we can expect so many questions from TRB, right? So system classification, right? So in system we are having what is this? Static and dynamic system. Second one, causal and non-causal. Third one, linear and non-linear. Fourth one, time invariant and time variant. Fifth one, what you call stable and unstable. Fine. Okay, so first one, static. So before studying a classification, we must know some notation. So y of t, y of n. These are all present output. This we must know. X of t, x of n. These are all present input. Right? So similarly, y of t minus 1, y of t minus 2 up to y of t minus infinity, past output. Similarly for n also. So similarly, y of t plus 1, t plus 2 up to y of t plus infinity, future output. Similarly, x of t minus 1 to x of t minus infinity, and similarly x of n minus 1 to n minus infinity, past input. X of t plus 1 to x of t plus infinity, it is future input, right? Okay. So these are all the things we must remember. Right. From if you know this notation properly, then you can answer the questions very easily from this area. So first one is static and dynamic. Static and dynamic system. Static means memoryless. Dynamic means memory. Right? So a system is called static system. Whatever the concept I'm telling for continuous, applicable for discrete. A system is called static system if present output is a function of present input only. Right? So if in addition to present input, if it is a function of past input of t minus 1 up to infinity, future input or past output, then it is called a dynamic system. Right? So y of t present output, example, y of t is equal to 2x of t. So it is a function of only present input, so it is static. This present output is a function of future input, so it is dynamic. So like that we can solve any problem from this area. Next one, causal and non-causal. So whenever you want to check causal or non-causal, you check non-causal first. So a system is called a non-causal system if present output is a function of future input in addition to others, right? If your system is having future input, surely it is non-causal. Else, if there is no future, then it is causal. So whenever you want to check causal or non-causal, check non-causal first. So you see y of t is equal to 3x of t plus x of t minus 1. Here present output is a function of present and past. There is no future. If there is no future, it is causal. Y of t is equal to 2x of t plus 3x of t plus 1. Here you see future input comes. Once future comes, immediately you can conclude it is non-causal. Right? So there is a question now here. How present input depends on present output. That is a concept of non-causal, right? How present output depends on future input. Where we have this, right? So answer this in comment section, right? Okay. So here we can have some shortcut. If your system is having an equation like scaling, right, and time reversal, in your system equation, if scaling and time reversal appears, it is non-causal only. You don't need to check, right? So example, y of t is equal to x of 2t. Here you see scaling appears. So surely you can conclude non-causal. No need to check, right? Y of t is equal to x of t minus t, time reversal. So time reversal comes, so surely it is non-causal. So in your system, if scaling and time reversal appears, surely it will be non-causal, right? Okay, for further shortcut, you refer my EC8451 playlist, right? Next, time, okay, next system is linear system. Linear system, so linear system, a system which obeys principle of superposition. Right? So if the system obeys principle of superposition, then it is called a linear system, but we don't need to check all the things. We know from our school mathematics, linear means proportionality. So there must be proportionality between input and output. So y of t, it should be this one. So it should pass in our mathematics. This is a linear system. This is also linear, but in engineering it is not linear. So it is not linear. Our linear system should pass through 0, 0. Right? So you draw the curve for your given equation. If it is a straight line, surely it is linear system. Else it is non-linear system. That is a simple thing. So here you see y of t is equal to 2 e power x of t. whether it is linear or non-linear. So you see it is exponential. Exponential curve will be like this. It is not having a straight line. So blindly you can say it is non-linear system, right? So y of t is equal to 1 by x of t. We know fraction is a non-linear from our school days. So blindly you can say it is non-linear system, right? It is easy to find a non-linear. You see y of t is equal to log x of t. So log is a non-linear function. So surely you can say the system is non-linear system, right? So like that you can say y of t is equal to x of t plus 3. So in mathematics it is linear. Y is equal to x plus 3. Ms plus c is a linear equation, but here it is non-linear because you see I told the signals, the system equation or graph should pass through 0, 0. So when x is equal to 0, y must be 0. But when you put x is equal to 0, y is 3, not 0. So when x is equal to 0 implies y is equal to 3. But linear system, as per the definition of signal system, you should pass through 0. X is 0 means, here you see x is 0 means y must be 0. So here also you substitute, you see when x is equal to 0, y is equal to 1. So x is 0 means y is 0, y is equal to 1. It is not satisfying. You can say that is not linear. Like that also you can say. So here the system is non-linear system, right? Substitute x is equal to 0, find it. So like that you can find. For further shortcut, you refer EC 8451 playlist and the concept, right? Okay, next one, time invariant system, right? So time invariant system means shifting input should produce shifting output. That is called time invariant system, right? So if there is a shifting input, there must be corresponding shifting output, right? Okay, so how can we find? You see y of t is equal to 2x of t. You follow the 3 steps I am giving, that is enough. So first step, right? So first step, you find shifting input. So shifting input, you have to shift the input. So input is shifted by some k unit. So this right hand side you can write y of t minus t comma k. Then you shift output. Shifting output by the same k, y of t minus k. So in t everything is replaced by t minus k. So 2x of t minus k. Right? You compare these two equation 1 and 2. If 1 is equal to 2, it is time invariant. Here 1 is not equal to 2, it is time variant system. Right? So the same thing you can apply for all the discrete time signal also. Then we must remember some important series for calculating energy and power and some other Z transform and all for discrete time signal. Those are all the things I give here. So summation n0 to infinity a n is equal to 1 by 1 minus a, where mod a must be less than 1. Then summation n goes to 0 to n minus 1, a n is given by 1 minus a n divided by 1 minus a. Here also mod a must be less than 1. Right? Then summation n goes to 0 k to infinity a n is given by a k divided by 1 minus a mod a is less than 1 again, right? So these are all the formulas which will be used when you work on energy and power and Z transform. So n goes to 0 to n, right? So these things they have to remember. And one more formula is n goes to 0 to n square. So that is given by n into n plus 1 into 2n plus 1 divided by 6. Right? So these things we must remember. Now we studied about signals and system. So if you take LTI system, this is x of t, this is y of t. Right? So what is the system is doing? All the system we are studying in our subject is LTI system. So x of t is input, y of t is output. So how output is related to input? Y of t is given by convolution between input and impulse response h of t. So what is impulse response? When input is unit impulse, what is the output we are getting is impulse response. So when x of t is del of t, what is the y of t value? That is called impulse response. So h of t characterize any system, right? So that is very important point. Okay, so output is a convolution between input and impulse response. So we must know some basic convolution, so that may be useful in exam for solving the problems. So what are those? E power minus at star e power minus at. For this, answer is t into e power minus at u of t. So here add u of t, here add u of t. Similarly, u of t star u of t, that is given by t into u of t, right? So next one, e power at u of t star e power bt u of t, that is given by e power at minus e power bt divided by a minus b, provided a is considered greater than b. So whatever the greatest number, that you consider as a, right? So this is another one important point. So these are all the formula. In discrete, we know x of n convolution with the unit impulse, that will give summation n goes to 0 to n x of n, right? So similarly, an un convolve with an un, that will give n plus 1 n plus 1 an, right? So it is like the same e power at into e power minus at, that is convolution formula. Here t, here n plus 1. What is the reason? You just find out. Okay, so that is important point we must know in convolution. Then some graphical convolution. This is t a1 x of t convolve with this is t h of t. So x of t convolve with h of t a2, what we get is this, both are square wave, so both are having the same length. So 0 t 2t, here it is a1 into a2 into t, right? So this is very important basic, some shortcut formula, you can use it during the exam. Okay, so that is the point. Here you see convolution is given like this, convolution symbol is like this. So whenever we are performing convolution, we have to do 4 operations: folding, shifting, multiplication, addition. Right, so convolution involves multiplication and addition, that's why this symbol is used, right? So these are, suppose if you want a convolution in discrete domain, x of n 1 2 1 2 and h of n is given by 1 2 1 1, so we have to form matrix. So we know, you all know how to solve that. So using that method you can solve. So suppose x of n is having n1 samples, h of n is having n2 samples. What is the thing I have to do is y of n should have n1 plus n2 minus 1 sample. So here x of n is having 4 samples, h of n is having 4 samples, so y of n should have 7 samples, right? So that is the one thing we must remember. So these are all the things you must know about impulse response and this one. So what is step response? Step response, you know, if you integrate impulse, we will get step. So if you integrate step response, you will get impulse response. So h of t dt, right? So integration of step response will give impulse response. Similarly, impulse response is differentiation of step response, right? So simply if they give h of t as 1 minus e power minus t and they ask what is step response, no need to worry, simply you can step response I write as s of t, differentiation of this, it is e power minus t, right? So simply you can find. So these are all the things you must know about what do you call systems and signals. Then we have to have technology to analyze signals and system. So to analyze signals, we have Fourier transform, right? To analyze system, we have Laplace and Z transform, right? So we have studied about what you call continuous time signal, discrete time, periodic and aperiodic. So when we have to use Fourier transform, when we have to use Fourier series, we will see, right? So this is periodic, this is aperiodic, this is continuous, this is discrete. So whenever you have periodic signal, we have to use Fourier series. So it is continuous time, discrete time. So time is continuous. So continuous time Fourier series simply called Fourier series. Whenever you are having Fourier aperiodic signal, we have to use Fourier transform. So periodic means series, aperiodic means Fourier transform. Since it is continuous time, it is discrete time, discrete time, discrete time, discrete time. So we must know Fourier series. CTFS simply known as Fourier series. DTFS is called discrete time. So continuous time means you don't need to tell CT, simply Fourier series. Simply FT means continuous time Fourier transform or simply Fourier transform. Both are same only. So from this what I understand, periodic signal means I have to use Fourier series. Aperiodic signal means I have to use Fourier transform, right? So similarly, if you want to analyze continuous time system, we have to use Laplace transform. That's why we are using in control system, we are using Laplace transform. Whereas for discrete time system, we have to use Z transform. That's why we are using Z transform in DSP. It is a discrete time system. All filters, right? IFI, RIR, those things are analyzed by using Z transform. So next, what we have to say, Fourier series. For communication engineering, main thing we need is exponential Fourier series, right? So Fourier series means simply it is continuous time Fourier series. Why we are using? For analyzing periodic signal, right? So what Fourier is telling, x of t. X of t is a periodic signal that is given by n goes to minus infinity to plus infinity a k e power j k omega naught t, right? So this is harmonics. Omega naught is a fundamental frequency, harmonics, right? So from this ak is given by 1 by t integral x of t e power minus jk omega naught t, right? So you see here e power j, here e power j, right? Complex exponential. Okay. So what Fourier is telling, any periodic signal can be expressed as infinite sum of harmonically related complex exponential, right? So everywhere you see this complex exponential. This is what Fourier says. So x of t is a periodic signal. I can write this in this form, right? So this is called synthesis equation. This is called analysis equation, right? So similarly, this is Fourier series, CTFS, right? So for Fourier transform, we know the equation is given by x of omega, that is equal to minus infinity to plus infinity x of t e power minus j omega t dt. For inverse Fourier transform, x of t is given by 1 by 2 pi minus infinity to plus infinity x of omega e power j omega t d omega. Again you see complex exponential, right? So okay, so what it is doing, Fourier transform is converting time domain signal into frequency domain signal. So whenever you want to convert time domain into frequency domain signal, you should have Fourier transform. So That is, if you want to find the frequency of the signal, go to Fourier transform. Frequency domain to time domain, we have to take inverse Fourier transform, right? So this is Fourier transform, right? That is very important one. We know that. Okay. Next one is Laplace transform, right? Okay. First I finish signals, then I go to system. Laplace transform. Sorry. Discrete time Fourier transform. Discrete time Fourier transform, what it will do, as the name itself is telling, Fourier transform is converting continuous time domain signal into frequency domain signal. So this is n goes to minus infinity to plus infinity, right? So inverse DTFT is IDTFT is given by 1 by 2 pi minus pi 2 plus pi x of e power j omega n d omega. Again you see complex exponential. Again you see complex exponential. It is time. We know it is time instant. Right, so what discrete time Fourier transform is doing, it is converting discrete time signal into discrete frequency domain signal. So if I want to go from x of n to frequency domain, you take dt of t, right? So if I want x of n from x of e power j omega, you take I dt of t. Right, x of e power j omega to x of n, if you want, you take inverse discrete time Fourier transform, right? And again you see this is minus pi 2 plus pi. What is the reason, right? You can comment in the comment section why it is not minus infinity to plus infinity. Okay, so these are all the things you must know. Then Laplace transform, right? So Laplace transform is given by Laplace transform of x of t is known as x of s, right? So x of s is given by x of t e power minus st dt, minus infinity to plus infinity. We know s is equal to sigma plus j omega. Again you see e power minus sigma t e power minus j omega t. Again the complex exponential, right? Why? Okay, so what it will do, it is Laplace transform converts time domain signal into s domain signal, right? So for that you need Laplace transform, and it is used to analyze continuous time system, right? So if you compare Laplace and Fourier transform equation is minus infinity to plus infinity x of t e power minus j omega t. So compare both the equation. When you compare, this is everything is same, right? Except one, this dt. Only one thing is instead of s we have j omega. So in Laplace transform, if you substitute s is equal to j omega, you will get Fourier transform, right? We know that. Why? We know e power minus a t u of t. For that Laplace transform is s plus a. For that Fourier transform is 1 by a plus j omega. You see this s is replaced by j omega. So if you want to find Fourier transform, then you can, from Laplace transform, first find Laplace transform, replace s by j omega. So we can get Fourier transform simply, right? Okay, similarly, next one is Z transform. Z transform, we know it is used to analyze discrete time system, right? So discrete time system I can analyze. So x of z, that is given by n goes to minus infinity to plus infinity, x of n z power minus n, right? So you see here, it is time domain signal is converted into z domain signal. So you take DTFT equation is this one. Compare both the things. You find Z transform, replace Z is equal to e power j omega. What you get is DTFT, right? So if you know only one transform, if you don't know other transform, means use only one transform and get the answer from that. right? So if I want to convert Z transform into DTFT, wherever you find Z, replace by e power j omega. Suppose if you are having h of z is equal to z by z plus 1, if they ask what is a DTFT, simply you replace h by e power j omega, e power j omega, e power j omega 1. So take e power j omega outside, right? This is e power minus j omega plus 1, right? Sorry. This is e power minus j. Okay, 1 minute. This is e power j omega, e power j omega. I take outside 1 plus e power minus j omega, right? So this is the DTFT, right? So in that way you can find DTFT from Z transform. So next, so in this way we can find Z transform from DTFT and all, right? So if what is the relation between Z transform and Laplace transform? If you substitute Z is equal to e power st, then we can convert Z transform into Laplace transform, right? So if I want to convert Laplace into Z, right? So h of s into h of z, what we have to do? We replace s is equal to 1 by 2 ln z, right? When you substitute s is equal to 1 by t ln z, it will become z transform, right? So this is the way both the Laplace transform and the z transforms are related, right? Next important thing is we should know about this h of t in detail. We know h of t is impulse response, right? Okay, fine. What we have to do is we are having h of t impulse response. So if you take Fourier transform for this impulse response, what we get is h of omega, because Fourier transform converts time into frequency. If you take Laplace transform of this, what you get is h of s, right? How can you convert Laplace into Fourier? If you want to convert Laplace into Fourier, we have to replace s by j omega. How can you convert Fourier into Laplace? J omega is equal to s. So this is very important triangle. From this you can answer any question. H of t, we know it is impulse response. H of omega is called frequency response. So how can you get frequency response from impulse response? We have to take Fourier transform of impulse response. H of s is transfer function, right? How can you get transfer function from impulse response? We have to take Laplace transform, right? So from frequency response, how can you get transfer function? Replace s by j omega, right? Sorry, from transfer function to frequency response, replace s by j omega. From frequency response to transfer function, replace j omega by s. So this triangle is very important. So let us see that. So y of t is equal to x of t. This is the equation they are giving. So if you take y of Laplace transform, y of t is having a Laplace transform of y of s, x of t is having a Laplace transform of x of s. So y of s divided by x of s is equal to 1. So it is Laplace transform of output, y of s, Laplace transform of input. So that is called a transfer function, right? So h of s, transfer function is 1. If I take inverse Laplace, so for this inverse Laplace, if I take h of t, h of s is having inverse Laplace of h of t, for this del of t. So impulse response is 1, del of t, right? So if I want frequency response, what I have to do? I have to replace s by j omega, that is equal to 1, right? So in this way we can find anything from other, right? So from here to here you can go, from here to here you can go, right? So take Fourier transform of h of t, it will give h of omega. Del of t Fourier transform is 1, so we can get this. So anything we can find by using this triangle, right? So this is the important triangle, right? Okay, so these are all the things we must know. Okay, and regarding Laplace transform and Z transform, they are different from Fourier in one sense, that they are having ROC, region of convergence, right? So region of convergence, Z transform is also having region of convergence. No ROC in Fourier transform. right? Okay, so answer it in the comment section, right? Okay, so this is a very important point we must know. ROC in Laplace and Z transform. So in this area they are asking lot of questions in TRB, right? So please study this area very well, right? If you want a detailed analysis, please refer my EC 8451 signals and system playlist. So there you can get any idea. Okay, so next one, DFT. DTFT spectrum is continuous. So it is very difficult to work on DTFT in system. So in order to make it possible in system, we have to go for DFT. So it is continuous. Here the spectrum is discrete. So how can you convert continuous into discrete? So if you want to convert continuous into discrete, we have to use sampling. So already DTFT is a frequency domain. So if you sample that DTFT spectrum, then we can get DFT. So DFT is a frequency sampled version of DTFT. Frequency sampled version of DTFT. Right? Okay. So what is the thing? So we know DTFT is given by e power j omega summation n goes to minus infinity to plus infinity x of n e power minus j omega n. Right? Whereas DFT equation we know x of k is equal to summation n goes to 0 to n minus 1 x of n e power minus j 2 pi by n into nk. Where I sample, here you see the relationship in this area. Again, complex exponential. What I am doing here, I replace omega by 2 pi by n into k, right? So this is the area we sampled. So here only we sample frequency domain sampling. At this point we are sampling, right? So we know. So it is like this. This is 2 pi by n is number of 0. Let us take this point is 2 pi by n into 1. So 2 pi by n into 2. 2 pi. Let us take for n point DFT. 3, 2 pi by n into 4. 5, 2 pi by n into 5. 2 pi by n into 6. This is 2 pi by n into 7. Right? We know that. So if this circle is spectrum of DTFT, instead of that in DFT what we are taking only this point 1 2 this if it is 8 point DFT we are taking this one this one this one this one, right? So that's why you see the k is having a value from 0 to n minus 1. So it is discrete. Whereas omega is, I asked one question already, integral goes from minus pi to plus pi. What is the reason? So it is continuous spectrum, it is discrete spectrum because k varies from 0 to n minus 1. This is integer, right? Discrete instant. So k discrete, right? So spectrum of DFT is discrete in nature, right? Okay. So next one, here it is the DFT, right? So DFT spectrum is discrete in nature. So DFT calculation is tedious. So to make it simple, we go to FFT. So FFT is not a transform. It is algorithm to find DFT. Right? So here they ask some questions in FFT, DFT. What is the thing? So in FFT and DFT, number of complex multiplication is, in DFT we are having n squared multiplication, n into n minus 1 multiplication in FFT. number of complex, it is complex, not real. Complex multiplication. Complex addition is in DFT, it is n minus 1, right? Sorry, please forgive me. In DFT, number of addition is n into n minus 1. In FFT, number of complex multiplication is n by 2 log n base 2. In FFT, number of complex multiplication is n log n base 2, right? So FFT and DFT both are same only. By finding FFT, what you get is DFT only. But why we are using FFT? Because FFT reduces computational complexity. So when you substitute n is number of sampling point, right? So if you take any number of n and solve the problems, we can see FFT has very less calculation compared to DFT. So that's why FFT is preferred everywhere in practical applications, right? So these are all the things we must know. So in DSP, we are having only two concepts. One is DFT that I told already, right? So DFT means DFT and filtering. These are all the two concepts in DFT. Right, so in DFT we have both, that is Fourier transform. Simply I can say Fourier transform, DFT and FFT. So no need to say, right? So DFT and FFT. In filtering we are having IIR and FIR, right? So these are all the two concepts, but here they give least importance. So just you refer all the theory and problems from this area, but DFT and FFT also some little bit of problems or theory may come, right? So in filtering IR, infinite impulse response, and finite impulse response. Infinite impulse response and finite impulse response. Why it is infinite? How it is infinite? That is very important question. Finite impulse response, it is always stable. FIR filter is always stable. It is having linear phase and it is all zero filter, right? So by using a pole zero diagram itself, we can find all the things. So it is all zero filter, right? So if your system is having only zeros like this, right, you can say it is FIR. If your system is having both poles and zeros, then you can say it is IIR filter, right? So that is the one thing we have to remember. So for FIR filter, pole is at origin. That's why it is called always stable. Linear phase means phase is a linear function of frequency. In FIR, omega phase, that is going like this. It is like this, or anyway, it is a linear function of frequency. When phase varies as a function of frequency, so pi of omega is equal to minus k omega, right? Where omega varies from minus pi to plus pi or 0 to 2 pi, right? So phase is a linear function of frequency, so that is very, very important, right? Ideal filter design is not possible, that we must know. Ideal filter is not possible because it is non-causal and unstable. Alright, so I think I forgot to mention about stable and unstable system, right? So stable system and unstable system and unstable. Okay, so if bounded input produces bounded output, bounded input produces bounded output, then it is called a stable system. What do you mean by bounded input? Input is not infinity. Sorry. So it should be having some finite value. So let us assume input is some finite value. That should not be infinity. That is called bounded input. If this one produces magnitude is not, again, it is some finite value which is not infinity, bounded output. If bounded input produces bounded output, then I can say the system is BIBO stable system, right? So here you see y of t is equal to u of t, x of t plus 2, So if it is some finite value, bounded input plus 2, finite plus 2, you will get bounded output only. So it is BIBO stable system. So simply how can I find at any point of time when at t tends to infinity, y of t should be finite. Then it is BIBO stable system. Right. So here you see y of t is equal to e power x of t. This is unstable system. Why? Because when t tends to infinity, e power infinity is infinity. So it is not BIBO stable. So not BIBO stable. Right. So again you see y of t is equal to x of t into r of t. When t tends to infinity, what will happen to r of t? R of t becomes infinity. So when t tends to infinity, y of t becomes infinity. So always it should be bounded, right? So it is unstable system, right? Suppose if they give y of t is equal to like this, here you see what is this? The amplitude is 1, right? So whatever be the time, the amplitude doesn't become infinity. So it is BIBO stable. So like that we can check whether a particular system is stable or unstable system. And moreover, from control system, the same concept is used. If poles lie in the left half of S plane, then it is stable. If poles lie here, unstable. Right half of S plane. S plane contains sigma j omega. If poles here, it is marginally stable. Similarly, in discrete domain, if poles are inside, stable. Suppose if poles lie outside unit circle, that is 1. Outside unit circle, unstable. If poles lie on border or on the circle, marginally stable. Right? So these are all the points we must remember whenever we are working with stable or unstable system. All the things are defined with respect to transfer function h of z. For discrete time, transfer function is h of z. For continuous time, the transfer function is h of x. So this is applicable here. This is applicable here. Okay. So these things we have to know, right? So I hope I have covered most of the things. It is just a review only, right? If you want detailed problems and solutions, right? So and full concept, you refer EC8451 playlist, signals and system, right? So your doubts will be cleared with the detailed explanation there, right? So next, what we have to do? We have to simply analyze SS in one problem. All concepts in one problem. What is that? Let us see.
Hi students, welcome to the session on signals and system. Here I try to explain all the topics that we are going to study in a signals and system with only one problem, right? So I take only discrete time system, and the same thing is applicable for continuous time system also. So let me take one problem and explain all the concepts that we learned. Okay, let us see. Let us take this problem. The output y of n is equal to x of n plus x of n minus 1, right? So any system with the output y of n is given by the sum of input, present input and past input, right? So this is a system. This equation is talking about the system. Now what we know, first we check in unit number 1 we studied classification of system. Let us classify the system. First thing is, what is this? It is dynamic system. Fine. So why it is dynamic system? Present output depends on past input. So it is a dynamic system. First thing we got. Second thing is whether it is causal or non-causal. Present output doesn't depend on future input. It depends on only present input and past input. So it is causal system only. Fine. Okay. Whether it is stable system, yes, at any point of time, if you give bounded input, suppose if x of n you give bounded input, this is another bounded input. If you add it to bounded data, the output will also be bounded. So the system is BIBO system. Okay. Next. So from here you will understand whether it is linear system or not. It is absolutely linear system. You know how to check that. So we can say that it is linear system. Then whether it is time invariant, yes, by seeing the equation we can say it is time invariant. So if you have any doubt about what is linear and time invariant, please refer my video on linear system and time invariant system. So simply it is LTI system. Clear? So what is the thing? If it is LTI system, convolution can be applied. For any input we can get the output. Okay. Now this is what we studied in unit number 1, classification of system. Right? Now let us apply Z transform. What will happen if you apply Z transform Y of Z? So here it will become x of z plus z inverse x of z. Okay. So what it will give? It will give, I take x of z outside and bring here y of z by x of z. Output of z transform divided by input of z transform is transfer function, that is given by 1 plus z inverse. This is what we know as transfer function or system function. This is the 7th data we get. Okay, fine. Okay, from transfer function, how can we get impulse response? We know. Take inverse Z transform. For this, if you take inverse Z transform of h of z, you will get h of n, that is given by 1 comma 1. You know how to take inverse Z transform. So this is what impulse response, the 8th data we got. Okay, right. So this is what our 8th data. This is our 7th data. Okay. Now we see what is the 9th concept we can get from here. If you apply z is equal to e power j omega, it will become h of e power j omega, and it will be 1 plus e power minus j omega. What is h of e power j omega? It is nothing but frequency response. So this is what our 9th concept we learned. You see, so we are having h of z. From that you take inverse z transform, what you get is h of n. Apply z is equal to e power j omega. What you get is h of e power j omega, frequency response. Right, from if you apply inverse dtft, what you get is again h of n. So it is a triangle. You can go from anywhere to anywhere, right? So you can do anything. So this is 9th concept. 10th concept, what we can learn, we learned is step response. Step response is the sum of impulse response. S of n is equal to a goes to minus infinity to plus infinity h of k. Here h of n is 1 comma 1, right? So h of k is 1 comma 1. Just a variable. H of k is 1 comma 1. So I find s of n. So s of n is step response, that is given by when n is equal to 0, what will happen? Right? It is k is equal to minus infinity to n. So when n 0, it will be k goes to minus infinity to n h of k. So s of 0 is 0 only, h of 0. S of 0 is k goes to minus infinity to n, h of 0 only, because n is 0 we substitute. So h of 0 is 1. S of 1 is k goes to 0 to 1. If you want to find 1, n is, we substitute n is equal to 1. K is not minus infinity, it has started from 1. 0 to 1. H of 0 is 1, H of 1 is 1. 1 plus 1 is 2. The summation. So we got step response. Here, 10th concept we learned. Fine. Next, 11th concept. We know that H of z is equal to 1 plus Z inverse. Okay, so whether it is a causal or non-causal, you see what is the pole zero diagram. Fine. So if you draw pole zero diagram, what will happen? The pole at 0, because 1 plus 1 by z, so the pole at 0 and 0 will be at minus 1. So minus 1 may be here, right? So z is equal to 0 is a pole, z is equal to minus 1 is a 0. So the pole lies inside a unit circle, right? So it is a stable system. Already we proved it is a stable system. It is another way of finding it is a stable system, right? And another thing is, you see the ROC is outside the outermost circle, then only it is called causal. Since pole at 0, surely it must be a causal. For a stable and causal system, pole must be inside a unit circle. So for stable and causal system, here poles at 0, so it is surely a causal system. Already we verified the same thing in the initial stage itself in a different way. Here we verified poles system in terms of what you call input-output relation. Here we verify the same stability and causality by using impulse response, transfer function. The same thing we can define, verify in terms of impulse response also. We know h of n is equal to 1, 1 we know. For system is stable, for stable system, the impulse response must be absolutely summable. Yes or no? So whether it is absolutely summable, sure. If you add 1 plus 1, you can get 2. So k goes to minus infinity to h infinity, h of k must be less than infinity. Surely, if you add impulse response, what you get? K, here k varies from, here instead of h of n, you can substitute h of k is 0, 1, 0 to 1, h of k, h of 0 is 1, h of 1 is 1, so to infinity, not. So 2 is less than infinity, finite number, so surely it is a stable system. This is another way to check whether a system is stable or not. This we studied. It is concept number 12 we studied. 13. When a system is said to be causal with respect to impulse response, a system is causal if impulse response should be having value for positive n. That is, h of n must be 0 for n less than 0. Here you see h of n is available at only n is equal to 0 and 1, not less than 0. So h of n is 0 for n less than 0. So surely it is causal system. Beautiful thing. Fine. So the system is causal system also. See, we verified causality and stability in 3 different methods. Right? All the methods are giving the same answer. Right? Next. This we studied. And 14th concept, h of n we know it is 1, 1. Fine. So if you see that, let us assume our input is x of n. X of n is 1, 2, 1. Right? Let us find the convolution y of n and find the output. What is y of n? Y of n is, we find the convolution y of n is equal to x of n star h of n. H of n I have taken something. For our equation y of n, h of n is equal, sorry, x of n I have taken some input. H of n is we found. So x of n star h of n is 1, 1, 1, 2, 1. You see 1, 1, 2, 2, 1, 1. So what is coming? 1, 3, 3, 1. So y of n is 1, 3, 3, 1. So for our impulse response, output is y of n for this input. What is our output equation? We know the equation is y of n is equal to x of n plus x of n minus 1. Here you see what is y of 0? Y of 0 is x of 0 plus x of minus 1. X of 0, 1. X of minus 1, no. So it is 1. Y of n. Y of 0. Y of 1 is x of 1 plus x of 0. So 1 plus 2, 3. Y of 2 is x of 2 plus x of 1, x of 2 plus x of 1, 2 plus 1, 3. Y of 3 is, y of 2 is x of 2 plus x of 1. Y of 2 is x of 2 plus x of 1. Y of 3 is x of 3 plus x of 2. X of 3, no, x of 3 is 1, so 1. You see, for our system, the output is pakka. So impulse response is perfect. So if you want your system to give output is a sum of present sample and immediate past sample, the impulse response should be 1, 1. Clear? So we got the output like that, right? So I think see, with one problem we have learned 14 concepts. Yeah. So this is, and the 15th concept we can see what is our h of z. H of z is equal to y of z divided by x of z. That is equal to 1 plus z inverse. How it is the hardware structure? Simple. I realize by direct form 1 of z, y of z, 1 z inverse. Okay. Here 1 comes, z inverse will come 1 plus z inverse. Right? So this is the simple thing. So with one problem, this is what we learned in signals and system with respect to discrete time system. The same logic we can apply for continuous time system also. And another thing we can still further get is what is the frequency response? 16. H of z is equal to 1 plus z inverse. Right? If you want to get frequency response, substitute z is equal to e power j omega. So 1 plus e power j omega. Take e power minus j omega by 2 outside. It will become e power plus j omega by 2. It is minus e power j omega by 2. So it will be like 2 cos omega by 2. E power minus j omega by 2 cos omega by 2. H of e power j omega. Fine. Take the magnitude. If you take the magnitude of h of e power j omega, what will happen? It will be simply 2 cos omega by 2. Right? So the magnitude is simply a cos wave with varying function of omega. So you see the magnitude of frequency response mod h of e power j omega when omega is 0, cos 0 to 2. So omega, this is omega. Fine. When omega is equal to 0, it is 2. When omega is equal to pi by 2, cos pi by 4, cos pi by 4 is 1 by root 2, 2 by root 2 is root 2. So it will come here. So omega is equal to pi by 2. When omega is equal to pi, it will become 0 because cos pi by 2 is 0. So you see, it is like it is a ideal low pass filter character with omega h of omega. This is low pass filter. Here it is a proved low pass filter or practical low pass filter because average is talking about low pass filtering. So this is perfect low pass filter, crude low pass filter. Right? See, with one problem, we can understand the whole thing. So this is what we study, right? So signals and system is very easy subject, right? So we can understand everything in a simple way. I hope you understand the concepts. If you have any doubt, please ask me in comment section. Thank you. Hi students, welcome to the session on Fourier transform of the signal. Alright, we all know that Fourier transform converts time domain signal into frequency domain signal. The formula to find the Fourier transform is x of omega is equal to minus infinity to plus infinity x of t e power minus j omega t dt. Right? If you have one black box which is called Fourier transform, if you give x of t as input, what you get is x of omega. So this is what our input time domain signal. It's a function of t, so it is time domain signal. After taking Fourier transform, what you get is frequency domain. It is a function of omega. X is a function of omega, so it is called frequency domain. So x of omega is nothing but Fourier transform of x of t. This we know. The question is how this equation gives omega. After doing this manipulation, right? So how t is becoming omega? That is the question arises, right? For example, if you take x of t minus e power j omega t dt, how it will give x of omega, right? That we normally ignore. We simply say x of t will give x of omega, but how it happens, let us see this now. Right, let us take one vector. We start with vector, then only we'll understand the concept. Let us consider a vector A. A is given by ai vector. For example, okay, ax x cap plus ay y cap plus az z cap. Let me write any vector like this. Ax, ay, and az are component of the vector along x, y, and z direction respectively. I want to find the component of vector A along x direction. What I will do, I will take a dot product of A with x. It will give Ax only. Similarly, I want to find the component of this vector A along y direction. What I do, I take a dot product with y cap. So what it will give? It will give Ay only. Other thing will be 0 because x dot y dot x is 0, y dot z also 0. Similarly, if I want component along x direction, I take dot product with z cap, it will give az. So what you have to do, if you want, A is a total vector, if you want to find the part of that, you have to take a dot product with its unit vector. Yes or no? This is vector, you have to take a dot product with unit vector along the same direction. So it will give the component of the vector on that direction. Similarly, this dot product has another name is inner product, we know. This is our vector. For function, the inner product is given by, for inner product of x of t, y of t is given by, this is the inner product symbol, we know, minus infinity to plus infinity, x of t, y of t dt. Fine, this is the inner product between two functions. But what is the thing, if I want to find the component of any vector, I have to take an inner product with unit vector. For vector, unit vector is x cap, y cap, z cap. For function, what is the unit vector or unit function? That's what complex exponential comes to play. What is that? E power minus j omega t. What is the magnitude? Magnitude of e power minus j omega t is always 1. Right? So that's why we choose complex exponential as the function. Now, what is the meaning of the equation minus infinity to plus infinity x of t e power minus j omega t dt? This indicates it is an inner product between a full vector like a vector A and what you call this fellow complex exponential or unit vector. Fine. So what will happen if it is similarly in vector, if it is x cap, it will give the component along the x direction. Y cap means it will give the component along the y direction. So with respect to the value of omega, it will give the value of the frequency at the particular value, for a particular signal. Why? We know that every signal is composed of harmonics, right? So if you assign some value omega, if you assign some value to omega, that frequency it will check. Only that frequency will be having a value, other value will become 0. Like if you take A into x cap, what will happen? Y component will be 0, z component will be 0, only x component only we will get. Like that, you take t varies from minus infinity to plus infinity. For example, let us assume omega is equal to 5. What will happen? If you take a dot product between these two, all the multiplication will become 0 except omega is equal to 5. Because at this frequency only it will make match, like our A dot x cap. even though A has x cap, x direction, y direction, and z direction, like ax, ay, az, but it will give the only value, only this multiplication exists, others are 0, no? Like that, only if phi is present, that value only will be available. That's what this frequency. If that phi is not present, the total function will become 0. In this way, a time domain signal is converted into frequency domain signal. Similarly, if our signal comprises of a 50 Hz signal, you substitute omega is equal to minus infinity to dt, t varies from minus infinity to plus infinity, it will take a dot product between x of t and e power minus j omega t. Only when omega is equal to 50, the answer will be available. For all other values of omega, the function will become 0. Right? So in this way, what happens? A time domain signal is converted into frequency domain signal by using Fourier transform. So, like any number can be represented by 1. Any vector can be represented by unit vector, right? Any signal can be represented by complex exponential. What is the commonality among all the things? The magnitude of all the values are 1, 1, 1, 1. Mod x cap 1, 1 is 1. Magnitude of 1 is 1. Mod x cap unit vector, that's why it is called unit vector. Magnitude is 1. Mod e power j omega t. Complex exponential, whether it is plus or minus, the magnitude of complex exponential is always 1. So this is very, very important point, right? So I hope you understand this, how Fourier transform is only giving frequency current of the signal. If you have any doubt, please ask me in comment section. Thank you. Hi friends, in this video we see shortcut method to solve convolution problems. We all know that solving the continuous time convolution is too tedious, but in a competitive exam, if they ask, we have a very less amount of time to solve the problem. So I give some of the shortcut techniques. It will be useful for you to solve the problem. Right? We know that convolution of signal input and impulse response is given by y of t is equal to x of t star h of t. We know we can solve this problem by using a graphical method or mathematical method or analytical method, right? But in exam we cannot do all the things because we have less amount of time. So how to solve this big problem in the shortest way? Use this shortcut, right? So first thing you must remember is the convolution between u of t and u of t is given by t into u of t. This you must remember, right? So based on this equation, they may ask different questions. We have to know. Fine. Okay. So by using this, we can create some shortcut. Let us see. Suppose if your input signal x of t is like this, 0 to t, and the time period is t, amplitude is a, and impulse response is h of t. That is also having a time period t, and amplitude is b, 0, right? So if you want to perform convolution between input and the impulse response, and you want to get output y of t, that is given by what we have to do is, the shortest method is, first you add starting point of input and impulse. The condition here is, you see, both input and impulse response are having the same amount, length of time. Here the time is t, total length of time is t, here also t. So that is a case 1. Let us assume this is case 1. Same length of time, amplitude is different. So at that case, what we have to do is, you add starting time period of both input and impulse response. This is 0, this is 0. So your output should also start at 0. You add ending time of input and impulse response, t, it is t. So t plus t is 2t. That is the end time of output. So t plus t is 2t. Now what we have to do? then it will go like a triangle, the output, right? So what about this peak value? This peak value is given by, what is this? It is amplitude of input signal. X input is A, amplitude of input is A, that is multiplied by amplitude of h of t, impulse response B, and time period t. This is what our output, right? This is the answer. Suppose in exam, if they give like this 0 to 2, 2, then convolve 0 to 2, 3 means this is x, this is h means what is our y? Y will be, it starts from 0, 0 plus 0, here it is 2, here also 2, 2 plus 2 is 4, and go like a triangle, right? What is the maximum output? 2, this value is 2 into 3, 6, and time period 2, length of the time is 2, so 12, the magnitude is 12. This is the shortest way to find the answer. Next problem, we take a similar thing. X of t is varying from amplitude A, time period 0 to t. This is my x of t. H of t is, what is the thing is, I change from positive amplitude to negative amplitude. Time period is same length t, but amplitude is b. So both are having the same length of time t, but amplitude is changed from plus to minus. Here what is the thing? As usual, add starting point 0. Here also it is 0. 0 plus 0 is 0. End point, add end point of time t plus t to t. Then what you have to do? Multiply amplitude of A, amplitude of B, amplitude of X is A, amplitude of H is minus B, total length of time t. So it is minus ABT. So amplitude changes from plus AB to minus ABT. It will be coming like this, right? So this is the one thing we must notice, right? So it is minus ABT, simple logic, right? Suppose, one example I give, suppose this is 0 to 2. If you want to convolve 0 to 2 with what you call, let me take okay, again 2 minus 1 means what is the thing? Add starting point 0, 0, 0, end point 2 plus 2 is 4, multiply amplitude of x 2 with amplitude of h minus 1, total length is 2. This is h, this is h, this is y, so minus 4, so it is 4. So this is what our y of t, right? Simple logic. This is x of t, h of t, y of t, right? So third case 3. Case 3 is something different. Suppose in both the cases we have seen amplitude is same. Time period, length of the time period is same. Here we see different length. For example, let us take h where x of t varies from 0 to t1 a. Convolve with h of t that varies from t 0 to t2. It length amplitude is b, where t1 is not equal to t2, that is the first condition, and t1 must be less than t2. Under this condition we can use this shortcut, right? So these two conditions don't forget. T1 should not be equal to t2, t1 must be less than t2. Under this condition use this logic, right? When happen like this, you see, when you have a x of t and h of t both are having the same length unit step, it will be a triangle. You see the result will be a triangle, right? So here, sorry, minus ABT, here I have to change it, not a rectangle, it is minus ABT means it will be like this. Here also it is triangle minus ABT, right? So you see when both here you see input is X, impulse H, both are having a unit step like that. So the result will be triangle, same length of unit step. Here also you see same length of unit step 0 to t, 0 to t. The result will be a triangle. Here in case 3 the length of the time is different 0 to t1, 0 to t2. When length of the time is different and what is the thing happening here is the result will be not triangle. It is trapezoid. So what we get is the result will be, as usual we start adding starting point 0 0, so 0 plus 0 0, then you go to the length of the first signal, that is x of t. So up to t1 you go, from 0 to t1 you add t1 value to 0, that is this point, then add t2 value to 0, so 0 plus t2 means it will go up to this. I told t1 is less than t2, so t2 will be right hand side only, then end point will be t1 plus t2, t1 plus t2 as usual. Now it will be a trapezoid like this point, right? So this is what our trapezoid. So what is the peak value? This is given by amplitude of x multiplied by amplitude of h multiplied by the lesser time period t1. So AB t1, right? So when the length is different, we will get trapezoid, not triangle. When the length is same, we will get trapezoid. For example, I give you, let us assume this is 0 to 2. 2. This is what our x of t. Convolve with h of t that varies from 0 to 3, 4. What happens? As usual, add a initial point 0 to 0, right? So 0 starting point is 0, so 0 plus 0 0. Add first time length of the time period t1, so t1 is 2, so 0 plus 2 2. Add second time period length, so it is the time period of h of t, it is 3, total length is 3, so 0 plus 3, 0 to 3, 0 plus 3 is 3, then add final value 2 plus 3 is 5. So what you have to do, I told you have to go to trapezoid like this. Yes, this is 0, this is t1, t2, t1 plus t2. I told you, right? What is the amplitude? Amplitude is amplitude of x multiplied by amplitude of h and t1. t1 is 2. So 2 into 8 into 2, 16. This is the convolution answer, right? Suppose, let me give one more example. It x of t is like this, minus 1 2 plus 1. This is what x of t. This is 2. Convolve with h of t minus 2 2 plus 2. This is 3. What I do, so here the length is different, right? Length is different, amplitude is different. Here the length is minus 1 2 plus 1 is 2, right? Minus 2 2 plus 2 is t2 is equal to 4, right? So find the difference. The length between minus 1 to plus 1, 1 minus of minus 1, 2. This 2 minus of minus 2, total length is 4. t1 is equal to 2, t2 is equal to 4. So as I told, if you want to find the y of t value, what you have to do, add starting point minus 1 minus 2. So we have to start from minus 3. From that we have to add t1. Minus 3 to minus 3 plus 2 is minus 1. So this point will be minus 1. This is what our t1. Next add t2 to starting point minus 3, t2 is 4. So it will go to 1. So this is minus 1, this is 0. Let me be 1 here, right? This is t2. Next t1 plus t2. Right? t1 plus t2 is here t1 plus t2. End point you have to t1 plus Okay, what is the thing? You add both the values. Endpoint is this is 1, this is 2. So this is 1 plus 2 is 3. Clear? So minus 1 plus 1, 3 may be here. So you go from here to here, then you come down. This is what the trapezoid. What is this amplitude? Amplitude of x2, amplitude of h3 multiplied by t1 value 2. So 6 into 2, 12. This is what our answer. Right? In this way we can solve the problem. Right? And another thing we must know that mainly they ask is what is the convolution between e power minus at star e power minus at. That is given by t into e power minus at. This is one of the important problem, right? And next this we must remember. And another thing they ask is what is the convolution between e power minus at star e power minus at u of t star e power minus bt u of t. For this the answer is e power minus bt minus e power minus at divided by a minus b u of t. Right? So e power minus a, this is the answer. Right? Suppose for example if they give question like this, what is the convolution between e power minus t u of t star e power minus 2t u of t? What is the thing? Here a is equal to 1, here b is equal to 2. So what we get is e power minus 2t minus e power minus t minus 1, a is 1, b is 2. So 1 minus 2. So that is equal to e power minus t minus e power minus 2t u of t. Here it is u of t, right? So this is the shortcut. This we must know. So e power minus at into e power minus bt is given by e power minus bt minus e power minus at divided by a minus b u of t. Right? And another thing is if they ask a convolution between e power minus at u of t star u of t, this convolution is given by 1 minus e power minus at divided by a into u of t. Right? This we must remember. Right? This is also a very important point to be noted. And another last point, the shortcut is e power minus at u of t star u of t plus or minus k is given by, as usual, 1 minus e power minus a t plus or minus k divided by a into u of t plus or minus k. Right? So I hope these methods, shortcuts will be useful for you to solve the problem in competitive exam. Right? Detail analysis, it's tedious. If you have any doubt on that also, you can ask me in comment section. I will clarify. Thank you. Hi students, welcome to this session on transforms and a complex exponential. In signals and system, we are going to study so many transforms, right? So all the transforms have some relation, and let us see what is the relation, what is the purpose of each transform now. Fine. Okay, so first we start with the Fourier transform. Continuous time Fourier transform. Fine. Okay, write fully. Continuous time Fourier transform. This is given by x of omega is equal to minus infinity to plus infinity x of t e power minus j omega t dt. So this will give the frequency of the continuous time signal. Fine. Since it is a continuous time Fourier transform, it will convert continuous time domain signal into continuous frequency domain signal. If you take inverse Fourier transform, we can get back original time domain signal. Right? So the corresponding discrete time Fourier transform is dtft. So here it will give x of e power j omega. It is also giving the frequency of the signal. Here it is continuous, so we put integration. For discrete, we have to put summation. The integral varies from t is equal to minus infinity to plus infinity. So in discrete, n only there, n varies from minus infinity to plus infinity. The signal is x of n and e power minus j omega n. Integration for continuous, summation for discrete. Here integral with respect to t. Here summation with respect to n, because it is a discrete. So what it will do? It will convert a discrete time domain signal into discrete frequency domain signal. We know it is time, it is frequency, it is time instant. N is time instant, omega is frequency. So we apply dtft. It is also giving the if you take inverse Fourier transform, we will get back our original signal. Fine. So from this we can find Fourier transform. We can go for Laplace transform, right? So the Laplace transform is very simple. Laplace transform is obtained by substituting s is equal to j omega. Not always. There is one condition is there, but normally it will work. What is that condition? I will explain in one another video. So when you substitute s is equal to j omega, Fourier will become Laplace. So you see x of s minus infinity to plus infinity, x of t, instead of j omega I substitute s, so e power minus st dt, right? So the equivalent version of Laplace transform in discrete domain is z transform, right? So here x of z, here integration as usual, discrete, summation. Integral with respect to t, here summation with respect to n. N goes to minus infinity plus infinity. X of n z power minus n. Fine. So this is what z transform. Okay. Here you see what it will do. It will convert time domain signal into s domain signal. Laplace transform. Z transform converts time domain signal into z domain signal. X of z. Z transform, right? Both have forward and reverse characteristics. You see that Fourier transform is used to analyze a periodic signal. It will find the frequency of a periodic signal, also periodic signal. DTFT is also, but it is continuous time aperiodic. DTFT is used to find the frequency component of discrete time aperiodic signal. Fine. Laplace transform is used to analyze continuous time system. It is used to analyze continuous time system. That is the main function of Laplace transform. And second function is it will convert differential equation into algebraic equation. That is a very, very important application of Laplace transform. Similarly, Z transform is used to analyze discrete time system, and it will convert difference equation into algebraic equation. That's a beautiful concept, right? We will see all the things when we study this transform. But you see that if you see all the transforms, you must have noticed one thing. What is that? Is e power minus j omega t. E power minus j omega. Here s is equal to j omega, again e power minus j omega. Here z is equal to e power j omega. So again z is the value of z is e power j omega. So all the transforms are having e power j omega. First, another thing you must remember is Fourier series. Fourier series states that any periodic signal, exponential Fourier series, I write, any periodic signal x of t can be written as infinite sum of, right, harmonically related complex exponential, right? So any periodic signal, x of t is any periodic signal, can be written in terms of infinite sum of this is what infinite sum, right? Infinite sum of harmonically related this is what harmonics a right? Harmonically related find complex exponential. Again you see complex exponential. Here also we have e power j. Fine. So why this is, you see all the transforms are having e power j, e power j, e power j, e power j, right? So what is the reason? The magnitude of complex exponential is 1 mod e power minus j omega t, that is equal to mod e power j omega t is equal to 1, right? So whenever you transform signal from one domain to another domain, that is for example x of t to x of omega or x of n to x of e power j omega, by using any transform, what should be the main condition? You should get back your original signal if you take inverse transform. It is forward transform, it is inverse transform. Inverse transform will give x of t if you have x of omega. So what is the thing? So when you transform, the originality of the signal should not be changed. Like when you put makeup, your original phase structure should not change. If it is changing and after that, the transform is like makeup, not like a plastic surgery. Transform is like applying makeup. It's not like a plastic surgery, right? So if you apply makeup, what will happen? Once you remove, you get back your original face, but you cannot get back your original face if you apply plastic surgery, right? So similarly, so when I can get back my original? Only when you multiply your signal with 1. Yes or no? For example, 10 multiplied by 1 will give 10, so you can get back your original 10, right? So that is the only thing. Similarly, when you multiply 10 multiplied by 2, find what will happen? 20. So this I can write as 2 into 1. So anything working with e power j omega t will not change the original magnitude, original value of the signal, because the magnitude of e power j omega t is 1. So it is like in all the transforms, it's like you are multiplying your signal or you are operating your signal with a factor of 1. So the originality will not change. Here also the originality of the x of t will not change. Here also it will not change. Here it will not change. Everywhere it will not change, because you are having a inner product with e power j omega t. The magnitude of e power j omega t is 1. So the originality of the signal will not change, right? Only it will change the form. If you apply inverse transform, you will get back your original signal. If you do operate with other function instead of e power j omega t, what will happen? The original signal will be modified and you cannot get back your original signal if you apply inverse transform. Whether it may be Fourier transform or Laplace or Z, you cannot get back your original signal. That's what we must know about these transforms and e power j omega t. I hope you understand this. If you have any doubt, please ask me in comment section. I will clarify. Thank you.